on how the different GUI frameworks operate. I'm going to use tkinter to show the difference between MVC and MVP, and I'll use pyqt with the UI definition file to illustrate MVVM. When you start creating a new application, choosing the right architecture is important, but there are lots of other things to consider as well. Today we're going to work with a really simple to-do list example. It's built on tkinter, it's one single file. I'll show you another version later that uses one of the architectures that we're going to talk about. Let me start by running this application. So this is what you get. So we have a list of to-do items here. I can add a new task, like so. Press enter and it's going to be added to the list. And I can click on one of these tasks and delete that, like so. How does this work? Well, there is simply a fixed constant value task list here that the application is initialized with. Later on, I'll show you a version of the same application that persists the task to a database, which is actually really simple to set up. Then we have some texts that are going to be used in the application. And then we have a single large class to-do list. Let me close the terminal. And this is a pretty simple class. It also contains a lot, and that's one of the issues that I'm going to talk about today. So it sets the title, it sets the size, it inserts the tasks from the task list variable that we get here as a parameter. Then it creates the user interface. So there are some things in the frame. There's a couple of buttons, a text field to enter a new task. And then we have a couple of methods like handling adding tasks, deleting tasks, things to do with selecting or deselecting tasks. This actually disables and enables the delete button. So that's pretty basic behavior of a to-do list application. Then we have a main function that creates an instance of the class, passes the constant that we saw at the top of the file, and then starts the main loop. And that's all it does. Now, this class obviously tries to do too many things. In particular, it handles both GUI aspects and data model aspects. And this is exactly where architectures like MVC or MVP or MVVM play a role. MVC stands for Model View Controller. It was created by Trygve Reenskog, which I completely screw up the pronunciation of while working on Smalltalk 79. In his design, a model represents the knowledge in the system. A view is a visual representation of the model, retrieving data from the model to display to the user and passing requests back and forth between the user and the model. A controller is an organizational part of the user interface that lays out and coordinates multiple views on the screen, and that receives user input and sends the appropriate messages to the underlying views. Smalltalk 80 supports an evolved version of MVC. Here, a view represents some way of displaying information to the user, and a controller represents some way for the user to interact with the view. A view is also coupled to a model object, but the structure of that object is left up to the application programmer. Showing different GUI architectures in Python or any programming language is actually pretty hard because we're also dependent on what the GUI libraries support. Now, I've tried to create an example of showing both MVC and MVP with tkinter because I think we're able to do that with tkinter. But for the MVVM version of the architecture, I'm going to use pyqt. So what we have here is a simple setup of model view controller. And the way that I've set this up is that the view is the graphical representation. So that's the file that you see here. So this is basically for a big part the class that we had in the simple version I showed you before. So that's a to-do list class. Then we have a model, and that model represents the data. So in particular, what you see that it's doing here is that it provides a connection with SQLite. So in the initializer, it creates a connection with the database, and then it checks if there is a table for containing the tasks. If not, it creates one. And then we have methods for adding a task, deleting a task, and getting the tasks that are currently in the system. So that's the model, that's the interface with the database. And then the controller is viewed as the system that passes the messages between the GUI and the model. So the controller then obviously needs a model and a view. So that's what it's getting here, and it's storing that as instance variables. And then it sets up the binding. So if you look at the view class, you see that we have, well, next to this create UI method that we already had before. So you see that we now have two new methods, bind delete and bind add, and those are going to provide the connection, the communication between the GUI and the model ultimately. And then that communication is dealt with by the controller. So for example, in order to add a task, the controller gets the text from the text field, it then clears it, it then adds a task to the database using the model interface, and then it tells the view to update the list of tasks, because of course a task has been added. And delete is very similar in that the model has a delete task. So from the view, we're going to get the selected task, and that's actually a property. Where is it? Yeah, it's down here. So this returns a string containing the selected task. And then the controller instructs the model to delete that task, and then it tells the view to update the task list. And then finally, the controller also has a run method that starts the main loop in the view. If you look at the main file, that's basically how it's set up. We create a model, we create a view, which is the to-do list class, and then we have the controller that is going to need both of them because it handles the communication. And then we call controller.run. So the controller really controls everything in the model view controller architecture. If you run this, you get practically the same result as before. So I can now type some tasks. I'm going to add a video script. I'm going to write a blog post, go to the supermarket. I can basically add these tasks here. And then if I close the app and I start it up again, you see that we get the same number of tasks because now it's persisted to the database. That's what the model is doing. And I can also delete tasks again. By the way, there is a bug in this specific implementation, namely that delete task simply deletes all the tasks that have a particular title. So if you have tasks with the same title, it's going to delete both of them. And that's of course not what you want in a to-do list. The reason I kept it in here is I wanted to keep the database really simple. Normally you would probably add some sort of ID to each task, and then you can delete it by ID, and then the problem is solved. So that's model view control. The model is completely independent. It's simply a layer on top of the database that allows it to perform operations on the data. The controller has both the model and the view and coordinates them. So if something happens in the view, the controller updates the model and then tells the view to update itself. And the view doesn't have any knowledge either of the controller, but it does have the model. So if you look at, for example, the update task list method, so what this does is that it gets the latest tasks from the model and then displays it on the screen. By the way, if you're enjoying the fact that the view has knowledge of the model, is one of the criticisms of model view controller, in that there is lots of connections between these three different things. The model is sort of independent, but the controller is coupled to both the view and the model, and the view is coupled to the model. So you get this kind of triangle of things that are dependent on each other, and that's not really great. An evolution of model view controller is model view presenter, and that tries to solve this issue. And that slightly changes the role of the controller. In model view presenter, that's called not a controller but a presenter, and it's serves more as a layer between the view and the model and handles the communication. And that's nice because that means if you change things in the model, then only the presenter needs to be updated and the view you don't have to touch. A second thing that you do in model view presenter is that you introduce some abstraction. In this case, the controller is dependent directly on this very specific view, and the view again dependent on a very specific model. And we want to separate those things a bit more so they're a bit easier to change. They're a bit more decoupled. So how do we set this up? Well, first we have the controller, and we're going to rename this to presenter. Like so. And then I'm also going to change the class name. Of course, this doesn't do anything. It's really for clarity. So there we go. Now in principle, we're not going to change a lot of things here, but mainly we want to remove the direct dependency on the to-do list view. So what I'm going to do instead is I'm going to introduce a class, and I'm going to call that view, and I will use a Python protocol for that. And for some reason that doesn't want to import automatically. So we'll just do it the old-fashioned way. So we have a view, and the view is going to have a couple of methods that we're going to use here. Now binding is something I'm also going to do differently, so I'll leave these two here for the moment. But we are going to need things like get entry text and clear entry. So let me add those methods now. So we have clear entry, that clears the text field, and we have get entry text. And that's going to return a string value, which is the current value of the text field. Now, before I change more things here, I want to update the view a bit. So on the side of the view, one of the issues is that the view was directly dependent on the model. So I want to change that. So one thing I'm going to do is simply remove this here, like so. And we're not going to store the model internally anymore. And when you look at the view, let me scroll down a bit, you see that actually the only place where the model is actually used is in update task list. What we can do instead is not let the view get the tasks from the model, but simply pass this value here as an argument. So I'm going to add here a list of strings, which is going to be the updated list of tasks. And then instead of getting it from the model, we can simply iterate over the task that we get as an argument. Another thing that I'm going to do differently is these bindings. So here we had methods to bind the delete and add tasks. But actually what's common in Model View Presenter is that the view has some sort of reference to the presenter. And the way we can do that is we have our create UI method that we pass here a presenter. And then since we have the presenter here, we can now perform the binding directly here. And then let's also introduce abstraction in the view. So we have a class presenter, which is again a protocol, which apparently I'm still not able to import automatically. And then this is going to have a handle add task, and that needs an event, and that's going to return nothing. And we have a handle delete task, like so. And now what we can do, since we have a presenter here, we're not importing anything, I'm simply using the protocol, actually model, we're going to remove because that dependency is now gone. And then here we pass the presenter, and then we perform the binding directly here. So we have two bindings. We have the delete task, so that's this one, and we can do that here. So we're going to bind it with presenter.handle delete task, and then this method, we don't need it anymore. And adding tasks, very similar. We have the my entry, and here we're binding that with presenter.handle add task. And then we also don't need this method anymore. So that's way cleaner in my opinion. And now I think we simply have to update the presenter a bit, because this should be handle add task and handle delete task. There we go. The bindings, we don't do them here anymore, which really simplifies the presenter a lot. And then let's change this to use the abstract view, the view protocol class. And now, of course, there are some things missing, like we don't have update task list, but we have update task list that expects a list of the current task, because that's what we added here. So let me add this method here. Update task list. And that's going to expect a list of strings and going to return none. And what we can do is let's create a helper function here. Update task list, and we're going to get the list of tasks like so, and then self.view.update task list, and we're going to pass the tasks. There we go. And now here, whenever we add a task or delete a task, we simply call that helper method to make sure that the task list is up to date, like so. The run method needs to do a couple of different things. View dot create UI. I think I called it create UI. Where is it? Yeah, create UI. So that one we also need to add here. Create UI self, and that's going to need a presenter, like so. And we need from future the annotations. Otherwise, this doesn't work. To-do list we can delete because that's no longer used. And then in run, we do self.view.createUI and we pass the presenter, which is this object, which is self. Then before we can actually start, we need to do self.update the task list. There we go. And then we can start the main loop. And we also need to add the main loop as a method. Main loop. There we go. So now the presenter really serves as an intermediary between the view and the model. So that's quite different from model view controllers, model view presenter. And there's abstraction. The presenter doesn't import the view. It simply has a protocol class. And the view also doesn't import the presenter class. It also has a protocol class. And since we set up the binding here, we can keep this relatively simple. And we have a couple of helper methods to change and update the view. We just need to change a few things in the main file. Now, of course, we don't have a controller anymore, but we have a presenter. There we go. We still create the model, obviously. We also create the view, but that no longer needs the model. And then we create the presenter. And just like before, the presenter gets the model and the view. So now both the model and the view, they are kind of separated from the rest of the code. Let me run this just to test that this actually works. And it doesn't. Why doesn't this work? In presenter, we have to create the UI, and apparently this is missing something. So we're passing self, so that should be okay. If I go to the view, we have create UI, we have self and the presenter. So why is this not working? Oh, actually, we don't have to do this anymore. That's the difference, because that's being done from the presenter. Let's try this one more time. Yeah, this looks better. We have go to the supermarket. Let me add something else. Say hi to my YouTube audience. And I'm not going to go to the supermarket because I just can't be bothered. So I'll delete that one again. So much better decoupled. Model is still independent. We actually didn't need to change anything in the model, but presenter has a view protocol class and view has a presenter protocol class. So there's some abstraction in there. Now I use protocols here. You can also use ABCs if you want to. They have a bit of a different kind of application. I did a video a while ago where I talk about the difference between protocols and ABC classes and when to use which one. I've put a link to that video at the top if you want to watch it. MVVM is yet another way of approaching things. Model refers either to a domain model, which represents real state content, that's like an object-oriented approach, or it refers to the data access layer, and that represents content. So that's more data-centric approach. Just like in the model view controller and model view presenter patterns, the view is sort of the structure, the appearance of what the user sees on the screen. And then it displays a certain representation of the model and retrieves the user interaction with the view. That can be mouse clicks or keyword input or anything. And then it forwards the handling of those to the view model via data binding. So data binding, that's the core difference, what separates model view model from MVP and MVC. The view model is then an abstraction of the view that exposes properties and commands. And then instead of the controller of the MVC pattern or the presenter of the MVP pattern, MVVM has a binder which automates communication between the views and the bound properties in the view model. The main difference between the view model and the presenter in the MVP pattern is that the presenter has a reference to a view, whereas the view model, if we change any of these, the pull a representation of the view, in this case using a .ui file. So this uses XML. I hate XML, but well, this is how it works. And here we basically specify the whole layout of the view and what things are called and whether they are enabled. For example, here you see we have the delete task button, so that works in exactly the same way. And then we have the model that is again based on the simple example I had in the beginning, where we simply have a constant containing a couple of tasks. And that creates a model and simply fills it. And I'm using here the Qt model, so I can easily couple it with the view. And then the view model is actually a class that provides the binding. So this loads the UI from the UI file that I defined here, and then it has binding. It already has the task lists and things like that. Now, this doesn't really work that well with the typing because obviously we didn't specify these things because they're generated from the UI file, But this handles basically the connection between what's in the UI file and what's in the actual view model. And then if you update the view model, it also updates the view. Now, strictly speaking, this is not entirely correct the way I set it up, because probably what this load UI thing does, it is simply generates the UI and it not so much provides a binding. But I think it's close enough to at least show you how it's supposed to work. And then what you also see here is that the view model then communicates with the model. So if we add a task here, that's on add task, then we're going to task list model, and there we can append a row. And when we delete a task, we're going to remove a row from the task list model. This is a bit of a contrived example because we don't really have MVVM in Python. But what I hope it shows is that the main difference between architectures like MVP and MVC and MVVM is that MVVM adds data binding to the mix. So there is this view, which is the representation of delegates to a template, which describes how the data is presented. Close is my preferred style.
But this book covers the more interesting bits. I chose the algorithm. A better way to for a list of 8 elements, log 8 equals 3, because 2 to algorithm running times. Chapter 2, as well as the pros and cons of each. There isn't one right way to store items for every use case, so it's important to know the difference. Arrays and linked lists. If another friend comes by, you're out of room again, and you all have to move a second time. What a pain. Similarly, adding new items to an array can be a big pain. The 6 of you are trying to find a place to sit, but the theater is packed. Some
Data structures and algorithms are an important aspect of every coding interview. This Algorithms and Data Structures course.
Hello everyone. So in our previous video, Hello everyone. So in this video, Hello everyone. So in this video we are going to discuss that how we can find the second maximum value in an array. So here we are Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss how to print elements of a singly linked list in Java. So friends, let's suppose we are given this singly linked list having 4 nodes with the data is 10, 1, 8 and 11. So in this tutorial we will discuss how we can print the data of the elements of this singly linked list. So below you can see the algorithm of it. So currently in the console you will see no output. So let's see the demonstration of this algorithm step by step. Now in the first step what we do is, in order to print the elements of the singly linked list, we need to traverse each and every node one by one, and we are given with the head node, which is the first node of the singly linked list. So we actually start traversing from this first node only. So in order to start traversing from this head node, what we do is we temporarily create a list node.
Today I'm going to talk about GUI.
Tell me what are the four numbers in that. So let's say 1, 2, 3, 4. Then in the next row,
Check. A better way to search.
In this lesson, we will introduce you to linked list data structure. In our previous lesson, we tried to implement a dynamic list using arrays, and we had some issues there.
Hello and welcome to the Easy to Advanced. Welcome back. This is when actually implemented. We'll get to this when we look at the source code's previous elements, because you don't have access to them. What to do is seek up to, but not including, the node we want to remove. So if we seek ahead, we advance our traversor pointer, and the next step is to change which point until we find her to be equal to 15. We have access to 4 and 15 because they are Trav's previous and next pointer respectively. Similarly, set 15's previous pointer to equal 4. Notice that Trav is now red, meaning it is ready to be removed. So we get rid of Trav, and now if we flatten out the doubly linked list, we see that it no longer contains 9. Let's do a bit of complexity analysis on linked lists. How good actually are linked lists? On the left column, we have singly linked lists, and on the right, doubly linked lists. The complexity for searching in a linked list is linear, hence we. However, removing from the tail is another story.
This is a beginner-friendly
search result. You can see here this was the number, the list of numbers, this was the expected output, and this was the actual output. So great. Using the less than, greater than, or equal to operators, so we can compare strings just like numbers in Python. So that will make it easy for us to implement these functions. And that brings us to the implementation. And the code for implementing these is also fairly straightforward. So now we have the user database class. We are actually implementing this class. And here you see that we have a constructor, and the constructor does not take any additional arguments apart from self. And all we do is inside self, we set a property .users, and that property .users is set to an empty list. Then we come to insertion. So now assume that we already have some users in our user database. So we start out with a pointer set to.
Hey, this is Andrew Brown, and I'm bringing. Hey, this is Andrew.
This is a beginner-friendly introduction.
Purpose of defining the functions str and repr within a class. And how are these two functions different? Now leave. Now what do you mean by a traversal? A traversal refers to the process of visiting each node of.
We will be implementing linked list in Python today, and we'll go through various operations on the linked list and the big O complexity. Let's test these two methods out. So first I'm going to create my linked list, and in